Right now, as you're watching this, light from the very edge of the observable universe is hitting your eyes, photons that have been traveling for over 20 billion years just to reach this tiny blue rock we call home. But here's the thing nobody tells you. That light, it is a wall, a boundary. And what is behind it might be the most terrifying thing science has ever uncovered. Most people think the universe is everything, that when you look up at the night sky, you're seeing all there is. But astronomers have known for decades that the observable universe, everything we can detect with our most powerful telescopes, is just a bubble. A tiny sphere of visibility around us, roughly 50 billion light years across. And beyond that bubble, that is where things get really weird. I'm going to walk you through what NASA, the James Webb Space Telescope, and some of the sharpest minds in astrophysics have pieced together about what lies beyond the edge of everything we know. And I have to warn you, the answer isn't comforting. Let's start with a question that sounds simple but absolutely isn't. What is the edge of the observable universe? See, the universe doesn't have an edge the way a table has an edge. You can't walk to the end of it and look over the side. The limit of the observable universe is actually a limit of light. It is called the cosmic microwave background, or the CMB, and it is basically the oldest light in existence. This is radiation left over from about 30,000 years after the Big Bang, when the universe cooled down enough for photons to travel freely for the first time. Think of it like fog. You're standing in the middle of a foggy field, and you can see maybe 100 feet in every direction. That doesn't mean the field ends at 100 feet. It just means the fog is blocking your view. The CMB is our fog, and everything beyond it is invisible to us. Not because there's nothing there, but because the light from whatever is out there hasn't had enough time to reach us yet. Now here is where your brain is going to start hurting a little. The universe is expanding, and it is not expanding slowly, thanks to something called dark energy, which makes up roughly 40% of all the energy in the universe. Space itself is stretching faster and faster every second. In fact, the galaxies at the very edge of our observable universe are already moving away from us faster than the speed of light. Wait, faster than light. Isn't that impossible? Here's the thing, nothing can travel through space faster than light. Einstein was right about that, but space itself can expand at whatever speed it wants. There is no speed limit for the fabric of the universe itself, and that creates a problem, a really unsettling problem, because it means there are galaxies out there, real galaxies with real stars and possibly real planets that we will never ever see. Their light is racing toward us at 20,000 miles per second. But the space between us and them is growing even faster. Those photons will never arrive. Not in a billion years, not in a trillion, not ever. We are permanently cut off from most of the universe. And when I say most, I'm not exaggerating. Current estimates from cosmological models suggest that the total universe could be at least 20 times larger than the observable universe in diameter. Some calculations published in astrophysical journals put it even higher, potentially 20 to the power of 70 times larger. That is a number so big it stops meaning anything to the human brain. Imagine the observable universe, all trillion galaxies inside it. Every star, every planet, every black hole is basically a grain of sand. The actual universe, that is the entire Sahara Desert, maybe bigger. And we're sitting on that one grain, convinced we can see everything. So what is actually out there, beyond the fog? This is where it gets fascinating, because scientists aren't just guessing. There is real data pointing us toward answers. The first clue came from something called the CMB cold spot. In Sunni astronomers studying the cosmic microwave background found an area in the southern sky in the direction of the constellation Eridanus that was significantly colder than it should be. We're talking about a void roughly 9 billion light years across with almost no galaxies in it. Now, cold spots in the CMB aren't unusual by themselves. Random fluctuations happen, but this one was too big, too cold, and too empty to be explained by standard cosmology. Some researchers at the University of Durham suggested that this cold spot could be evidence of another universe pressing against ours, like a fingerprint left on the surface of a balloon by another balloon touching it. That idea connects to one of the most mind-bending theories in modern physics, the multiverse. Now, I know what you might be thinking. The multiverse sounds like science fiction, like something from a Marvel movie, but the math behind it is surprisingly solid, and some of the most respected physicists alive today take it very seriously. The theory goes like this. Right after the Big Bang, the universe went through a period of insanely rapid expansion called cosmic inflation. In less than a trillionth of a trillionth of a trillionth of a second, the universe expanded by a factor of at least 10 to the 35th power. That is not a typo. The math really is that extreme. But here's the key insight that physicist Alan Guth and others figured out. If inflation happened once, the math says it should happen again. And again, different regions of space-time would keep inflating, budding off like bubbles in a pot of boiling water, each one becoming its own self-contained universe with its own physics, its own dimensions, possibly its own versions of matter and energy. Our entire observable universe, all sol billion light years of it, might be just one bubble in an infinite ocean of bubbles. And the terrifying part, each of those bubbles could have completely different laws of physics. In some of them, atoms might not form, stars might not ignite. In others, gravity might work in reverse, pulling everything apart instead of together. The James Webb Space Telescope has added another layer to this mystery. In Webb's deep field observations revealed galaxies that formed way too early in the universe's history. Galaxies that are too massive, too structured, and too mature to exist according to our current models. The Canuck survey found objects at redshift 40, and beyond that challenge, everything we thought we knew about galaxy formation. Some cosmologists have started to ask a disturbing question. What if these impossible galaxies aren't just anomalies? What if they're evidence that the physics in our bubble isn't constant? That the rules we've measured here on Earth might be slowly changing, or that they were different in the distant past in ways we didn't predict. And then there's the dark flow in Foy, and again in Foy-Nas. NASA scientists detected something they couldn't explain. Clusters of galaxies, hundreds of them, were all moving in the same direction through space at enormous speeds toward a point far beyond the observable universe. They called it dark flow. Now, within the observable universe, there is no known structure massive enough to be pulling these galaxy clusters. Nothing visible, nothing detectable. Whatever is causing this motion is outside our cosmic horizon, beyond the wall of light we can see. Some astrophysicists propose that this dark flow is being caused by the gravitational pull of matter in another universe, or a massive concentration of mass in a region of space we can never observe. Either way, something out there is pulling on our reality, and we have no idea what it is. Let me bring this all together, because this is the part that keeps cosmologists up at night. If the universe is truly infinite, or even just incomprehensibly larger than what we can see, then we face a reality that goes against every instinct we have as human beings. We are trapped inside a bubble of light, surrounded by an ocean of unknowable space, potentially filled with other universes that operate on physics we can't even imagine, being pulled by forces we can't detect, toward a destination we can't identify. And every single second, as dark energy accelerates the expansion of space, our bubble is getting lonelier. Galaxies that we can see right now will eventually cross the cosmic horizon and disappear from view forever. In about 50 billion years, future astronomers, if they exist, will look up at the sky and see nothing. Just their own galaxy floating in an apparently empty void with no evidence that anything else ever existed. They won't know about the 30 trillion galaxies we can see today. They won't know about the CMB. They won't know about the Big Bang. The universe will have erased its own history. And here is the brain twist. How do we know that hasn't already happened to us? How do we know there weren't things visible from our position a billion years ago that have already slipped beyond our horizon? Evidence that is already gone, information about the true nature of reality that we've already lost forever and don't even know we're missing. We might be looking at the universe through a keyhole, and the door is slowly closing. That is what is beyond the observable universe. Not nothing, something so vast, so alien, and so permanently out of reach that it makes everything we've ever known look like a rounding error in the math of existence. And the most terrifying part of all, we're not even sure the math is right. If this one twisted your brain, do me a favor and hit subscribe. I drop videos like this every Monday, Wednesday, and Friday, breaking down the most mind-bending mysteries of the universe. And speaking of mysteries, in the next video, we're talking about what the James Webb Telescope just captured that has astronomers questioning whether 5 entire galaxies should even be possible. I'll see you there.